Directories by Nico, Tim, Matt, and Victor. What is a directory? The term directory is used in computer software context and it refers to a container or folder that can hold files or other directories. A directory that is stored within another directory is referred to as a subdirectory. The directory acts like a filing cabinet. It allows users to store files and sort them into groups of related files. In many operating systems, a directory is simply called a folder. Directories provide organization and access control and allow you to logically separate files. There are several operations that a directory can do. Search for a file, create a file, delete a file, list a directory, rename a file, and traverse the file system. A directory has several structures that include single level, two level, tree structure, acyclic graph, general graph. Single level. This is the simplest type of directory. All files are contained in one directory. Each file needs to have a unique name. There are some limitations. A single level lacks separation and organization. It doesn't support multiple users. It can be confusing as a result of unique file name, and it becomes very difficult to maintain with many files in a single directory. Here's a visual example of a single level directory. As you can see, there's only one directory and all the files in it will have to be uniquely named. Two-level structure. Each user has their own user file directory, or UFD, which are subdirectories of the master file directory, or MFD. When a user refers to a particular file, only that UFD is searched, allowing for duplicate file names in separate users' directories. System files may be kept in a special user directory to avoid having copies of each individual UFD. User directories are protected. You can't accidentally delete another user's file of the same name. Now for some limitations. It isolates users from one another. It makes sharing and collaboration more difficult. It does not allow for better organization of files. Here's a visual example of a two-level directory. Notice how the directory above is the master file directory, and it contains different users. In each user file directory is beneath, each containing the files of that particular user. As you can see, naming does not have to be unique for each of the different users. They could have the same file names or directory names.
Tree-structured directories. This structure extends a two-level directory to an arbitrary height. Users can create their own subdirectories, allowing for better organization. A bit is used to define whether it's a file, 0, or subdirectory, 1. Each process has a current directory containing files of immediate interest. This current directory is searched first. Each file has an absolute path name, beginning at the root, and a relative path name, beginning from the current directory. Limitations. Special system calls must be used to create or delete directories. Deciding which policy, deleting empty directories, or allowing full directories to be deleted and risk accidentally deleting needed files must be chosen. Users still can't share files or directories. A user needs to specify a path or be in its directory in order to access a specific file. In this illustration of a tree-structured directory, we can see the hierarchical structure that directories often form. Acyclic graph directories. These directories allow for easy file sharing and collaboration, implemented through links or duplicate directory entries. A link is a pointer to another file or subdirectory. Duplicating directory entries copies all information in both sharing directories. The same file can be in multiple directories. Simple to reverse and determine whether there are no more references to a file. Limitations. A single file may have multiple absolute path names, causing confusion. With link entries, there may still be links pointing to a non-existent file after deletion. With duplicate entries, consistency may be lost when modifying a file. It's also difficult to ensure there are no cycles. In this illustration of an acyclic graph, we can see that the all and list directories contain the same file. General graph. What if we end up with cycles in a directory? Cycles are links that point back up the directory tree. When users add links that cycle back up the tree, they destroy the tree structure of an acyclic graph and turn it into a general graph. Cycles may cause the system to search the same subdirectory more than once. We must design against this. Limitations. Must institute garbage collection when deleting a file or subdirectory, which is extremely time-consuming. Must avoid searching any component more than once, as it may result in an infinite loop. In this depiction of a general graph, you can see a cycle formed by linking the AVI directory to the book directory above it. Finally, we have an example of an actual Windows directory structure. This depiction allows us to again visualize the hierarchical structure that is formed, and also see how related files are grouped together, providing logic and organization to the file system.
So here we have a file cabinet. One drawer can represent a single level because all files are in one directory. And two level, each user has their own drawer. These represent the user file directory, while the whole cabinet itself can be the master file directory. And the cool thing is, each drawer, the users can have the same file names as long as they're in separate drawers, pretty much. So let's say user 1 has file 1. So that's not an issue. The user 2 can also have a file 1. A tree structure expands on two level, pretty much allowing folders inside a drawer. So the user can create as many as they'd like, and the absolute path is pretty much the cabinet and anything inside it, while the relative path is everything from the file. So anything inside the apps folder, it can access.
A cyclic graph. This allows easy file sharing and collaboration. For example, in Windows, you can create shortcuts to directories. So here's a shortcut of the documents folder. They're both named documents pretty much. But now let's say, for example, user 1 has a file named file1.txt, and user 2, instead of having the same file, he has a link to the file. So he has a shortcut named file1.txt, which is the same file name, but instead it opens up the original file, which is located in user 1's documents folder. But now, let's say you decide to delete the file. So user 1 deletes the file, and now let's say user 2 wants to open it. When user 2 tries to open it, an error pops up saying that it doesn't exist and it's been deleted. And this is an example of a dangling link.